The next thing we're going to look at is finding probabilities using permutations, and what that means is finding the chance of things occurring when the order is important. Alright, here, so we're going to look at what this notation means in mathematics. We want to simplify each expression. Well, the forward exclamation point is what we call 4 factorial, and what that means is that you take that number and multiply it by everything underneath it. So 4 factorial means that you do 4 times 3 times 2 times 1, and this equals 24. 5 factorial means you take that number and multiply it by everything underneath it. So 5 times 4 times 3 times 2 times 1, and that is going to equal 120. 8 factorial, again, you take that number, multiply it by everything underneath it. Oops, I skipped 4. And when you multiply all that together, you get 40,320. Alright, so here, the first one here is how many different arrangements can we make with the letters in cat? Well, we could do cat. We could also do this. But what if the first letter was A? We could have this arrangement. Could also have this arrangement. The first letter was T. We could do this. And if you count all those up, there's 6 ways. Shortcut here is if we use factorial. Since there's 3 letters, and they're all different letters, we could do 3 factorial, which is 3 times 2 times 1, which is also 6. So the shortcut is to do the factorial. So if we look at the next one, the letters in the word math, there's 4 letters. And they're all different letters, so we can do 4 factorial, which means it's 4 times 3 times 2 times 1, which is going to give us 24 different ways to arrange the letters in math. Down here, for the last one, we have you and 4 friends. Well, 4 friends plus you equals 5 people. We want to see how many different ways can we arrange those 5 people in seats. So if we do 5 factorial, 5 times 4 times 3 times 2 times 1, that's going to give us 120 different ways for those people to sit. Alright, so the previous examples we didn't have any duplicating letters. In this one here, the letter O occurs twice. So the letter O, we have that occurring 2 times. So what we have to do, there's 4 total letters. So we have 4 factorial, but we have to account that if you switch the O's, it still looks the same. So since the O occurs twice, we're going to divide by 2 factorial. When you do that, we've got 4 times 3 times 2 times 1 all over 2 times 1. Well, that gives you 1, that gives you 1, and when you multiply 4 times 3, you get 12. So there's 12 ways different ways we can arrange the letters in pool. Now, if we're looking at the word banana, there's 2 letters that occur more than once. The A occurs 1, 2, 3 times, and the N occurs 2 times. Well, we have a total of 6 letters. So we've got 6 letters, so 6 factorial, but we have to account for the fact that if you switch any of the A's, it still says banana, or if you switch the N's, it still says banana, so it doesn't look any different. So we have to then account for each letter that duplicates, and that means we got 6 times 3 times 2, oops, I skipped some, 6 times 5 times 4 times 3 times 2 times 1, all over 3 times 2 times 1, and then 2 times 1. Well, there's a 3 here and a 3 there, that gives you 1. 2 there and 2 there, that gives you 1. As we multiply across here, we have 6 times 5 times 4, which gives us 120. And on the bottom, we've got 1 times 2 times 1, which is 2. And then 120 divided by 2 is 60. So there are 60 different ways to arrange the letters in the word banana. Alright, now we have the word independent. Well, in the word independent, the letter N duplicates 3 times. The D occurs or duplicates twice, and the E duplicates 3 times. Now, total number of letters in independent is 11. So we start with 11 factorial all over the letters that duplicate. So the N duplicates 3 times, the D duplicates 2 times, and the E duplicates 3 times. So we've got, 11 times 10 times 9 times 8 times 7 times 6 times 5 times 4 times 3 times 2 times 1 all over 3 times 2 times 1 times 2 factorial, which is that, and then again 3 factorial, which is that. When we simplify this, we end up getting 554,400 ways.